Good everyone, my name is Graphics. In this video, we are told to find the reaction of the figure that is displayed on the screen. Now, if you look at this figure closely, you discover that it is a overhanging beam. It is a beam that is what? Overhanging. Why did I say it's overhanging? Because one of its ends is extended, right? And this beam you're seeing here has two loading. The first loading here is a point load, and the second loading here is a uniformly distributed load. Also, this beam you're seeing here has two supports. The first support is at point E, which is the roller support, and the second support is at point G, which is the hinge support. Now, the first thing you have to do is for you to draw the free body diagram of this beam here, right? Now, the first thing you do, you draw a straight line from D to G, just like this, right? Then after that, you start dividing it into the distances that we have there. Because from the question we have here, we are told that D to E is 10 meter. E to F is another 10 meter. Then F to G is another 10 meter. So I'm putting them right there, right? Similarly, we have a point load at D. I'm going to put it there. And in between E and F, we have a uniformly distributed load of what? 2 kilonewton per meter. The 2 kilonewton per meter means that every meter is 2 kilonewton. So when you have 10 meter, it means 2 kilonewton per meter times 10 meter. You discover that the meter here will equate the meter here. We're left with what? 10. And 10 times 2 here is what? It is 20 kilonewton, right? Now, because of we have converted this to point load, it will now be situated at the center of the distance it covered. And what is distance between E and F? That is 10. So it will be in the center of it, which is what? 5 meter, right? So it means that from E to this point is 5 meter, and from this point to F is 5 meter, right? Similarly, we look at the next UDL here, which is having a force of 4 kilonewton per meter, right? So it means that every meter is 4 kilonewton, and we also have 10 meter between F to G. So it will be 4 kilonewton per meter times 10 meter. So the meter we equate the meter here, 10 times 4 is what? Is 40. So the 40 will now be acting at the center of the distance the what? The load covers, right? And that is also 5 meter. So I'll be putting it there, 40, acting at the center of what? F and G, right? Now, if you look again at point E, we say we have a reaction, a support, roller support. So the reaction of that roller support will be facing upward, right? So to be facing upward, a roller support has one reaction. Now you go to the next one, which is at point G, we have a hinge support, right? A hinge support have two reaction, which will be the reaction, the force facing upward, and the one going to the right. So I'm going to call that RGX, that is the horizontal one, and the vertical will call it ROGY. Just like the roller here, it will be called REY. All these things means reaction at point E along y-axis, reaction at point G along x-axis, reaction at point G along y-axis. That is what it means. Now, I have successfully transformed this UDL into point load, and also I've drawn out the free body diagram. Now, what we are told to actually look for here is to find the reaction of the support after all this load has placed on what? On the beam, because we know that a support is meant to react to a load. So what is the kind of reaction? What is the force of the reaction? That is what we are about to calculate for here. So now let's start. We need three conditions for equilibrium for we to be able to calculate this reaction, right? The first condition here is the summation of H equals to what? 0. When I mean H means horizontal, right? Or you can say summation of F of S equals to 0. They are both the same. It means that any force acting to the right must be equals to the force acting to the left. That is what that statement means. So if you look at our figure very well, the free body diagram we drew here, we only have only one horizontal component, and that is acting to the right. So I'm going to write it at the left hand side here, ROGX, right, equals to, is there any force acting to the left? No force. So I'm going to just put 0 here. So it means ROGX is equals to what? 0. Similarly, the second condition for equilibrium is the summation of V equals to 0. That means summation of the vertical component. You know, vertical component can either be upward or what? Or downward force, right? Or you say summation of F of Y is equals to what? 0. Now, what it means is that all upward force must be equals to downward force. That is what it means. Now, if you look at that system here, we have upward force, which is just ROEY and ROGY, right? These are the two forces facing upward. Now, if you look at the other one on it, we have downward force, which is the 10, 20, and 40. So you're going to put them on this other side for downward force. So it will be 10 plus 20 plus 40 because they are all facing down. That's why I'm adding them together. Now we will now say that my ROEY plus ROGY will now be equals to what? 70 kilonewton, which is as a result of what? 10 plus 20 plus 40. So we are going to term that equation 1. Now the next thing we're going to do is the third condition for equilibrium, which is summation of moment about any point of your choice. So I'll be taking point G, right? Because I have two unknown there, so I'll be taking point G to make my work easier. So when I do that, now we know about moment. We say moment is more of a turning effect, right? And it is the force times perpendicular what? Distance. It is the force times what? Perpendicular what? Distance, right? So from what we have here, we'll say that clockwise moment is equals to what? Anti-clockwise moment, right? So if you look at the clockwise moment now, let's see. If I take moment about point G, right, it means that every force will be acting towards point G. But point G will just be nothing other than what? A reference point. You will be looking at point G that there's no force on point G. Point G is just a reference point. So ROGX and ROGY is not seen. We assume that they are not there because you are taking moment at what? At point G. Now if you look at this closely, you see that the 4 kilonewton is acting downward. So it will be acting towards, look at direction, it has a direction downward. So it will be acting towards G, right? And that is the force going towards G. And look at the force going in this direction here, right? So going in this direction, and if you look when something is going in this direction, just like you can see here, we say it is what? It is anti-clockwise. So it will be the 40 times the distance point from the point of 40 to the point of what? Of G, and that is 5 meters, just like you can see here, right? So I'm going to multiply the 40 times the 5. But what do you notice is anti-clockwise. So it will be on the anti-clockwise part here, which will be, I'll write it here, 40 times 5. Similarly, if you look at the next force here, which is what? The 20 kilonewton. The arrow is also pointing downward. It is going towards G, right? And it's acting at this point. So from this point it is acting, it will be 5 plus 5 plus 5, which is what? 15, right? So it will be, and if you look at it, it's going anti-clockwise also. So 5 times what? That is 20 times what? 20 times 15, because the force there times the distance, that is the moment. the force times what? Times the distance. So when you do that, we're going to be having 20 times what? 15, right? In the anticlockwise part here. So look at the next one again, REY. Look at the direction of the arrow. The arrow is facing upward, right? And it will be going towards G. Look at the arrow, it will be going towards G. And that is what? That is clockwise. When anything is moving in this manner, it is what? It is clockwise. So I'll be putting it in my left-hand side. So the distance from where REY is to where you take moment, which is what? Point G, is 10 plus 10. And that is what? 20. Or you say 5 plus 5 plus 5 plus 5, which is what? 20. So we'll say REY times 20 at this side, right? And the last here at point D is the 10 kilonewton. The arrow is facing downward, so it's going towards this direction. You can see that. And when anything is going like this, we say it is what? It is anti-clockwise. So it will be the 10 that the distance of the 10 from is the 10 times the distance of the 10 from where the force is, right? So we have 10 times the entire distance here, that is what? 10 plus 10 plus 10, that is what? 30. So it will be 10 times 30, right? And that will give us what? 300. That 10 times 30, that will give us what? 300, right? So this is what we have here. I'm putting it at the anti-clockwise part here, right? So from here, 20 times REY will give us 20 REY equals to 40 times 5 is 200 plus 20 times 15 is 300, right? And 10 times 30 is what? Is 300, right? So from here, we'll be having 20 REY is equals to 800. And if you divide both sides by 20, REY will be what? 800 over 20. REY is equals to what? 40 kilonewton, right? Now you put REY into equation 1, right? So equation 1 is telling me REY plus RGY is equals to what? 70. So what is the REY? 40 plus RGY equals to 70. RGY will now be equals to what? 70 minus 40. So RGY is equals to what? 30 kilonewton. Is that taking you now? So that is the reaction of the support. So the reaction of the support at point E is what? REY, and that is 40 kilonewton. Reaction of the support at point G is RGY, and that is what? 30 kilonewton. And that is our answer there. So if you found this video helpful, please don't forget to like, subscribe, and also share the video. Thanks for watching.